Have you ever stopped to think that maybe there's a hidden mathematical code written into the world all around us? You know, a simple pattern that just keeps showing up in the most unexpected places, connecting everything from the microscopic to the massive?
I mean, take a look at a pine cone. It's right there, in those elegant, interlocking spirals. If you look closely, you'll see two sets of them, one winding clockwise and the other going counterclockwise. It's a structure so common we barely even notice it.
Or, hey, what about the petals on a daisy? Turns out that number isn't random at all. There's a very distinct mathematical preference at play.
And yep, it turns out both of these things, and a whole lot more, are governed by the exact same repeating sequence. It's like a hidden mathematical code that's embedded in nature itself. So, what is this pattern, and who on earth figured it out? All right, let's dive in and unravel one of the most fascinating stories in all of mathematics.
Okay, first up, let's just get a feel for how widespread this pattern really is. And I'm not just talking about a few cherry-picked examples. This code is, and I mean this, practically everywhere in the biological world. You see, this sequence dictates how leaves are arranged on a stem, making sure each one gets the most sunlight possible. It defines the little fruitlets on a pineapple and the flowering of an artichoke. And get this, it even shows up in the family tree of honeybees and the inheritance pattern of the human X chromosome. Crazy, right? And of course, the most famous example, those mesmerizing spirals in a sunflower, which just happens to be the most efficient way to pack seeds into a tight space.
So, who do we have to thank for bringing this incredible pattern to light? For that, we need to hop in the time machine and go back to meet the man whose name is now forever linked with this sequence. Let's see how this whole thing came together.
Now, here's the thing. We call it the Fibonacci sequence, but its origins are actually much, much older. It was first described way back around 200 BC in Indian mathematics by a scholar named Pingala. He was using it for patterns in Sanskrit poetry. It didn't even get introduced to Europe until 1202, and it took another 600 years before it finally got the name Fibonacci sequence in the 19th century. So the guy we credit with bringing it to the West, his name wasn't actually Fibonacci. He was Leonardo of Pisa, or Leonardo Pisano. The name Fibonacci is more of a nickname, basically meaning son of Bonacci. And because his dad was a wealthy merchant, he got to travel all over the Mediterranean, learning from merchants and mathematicians everywhere. But you know what's kind of wild? This sequence, it wasn't even Leonardo's most important contribution, not by a long shot. His biggest impact was championing the Hindu Arabic numeral system. You know, the numbers 0 through 9 that we all use today. He saw how much easier it was for merchants compared to those super clumsy Roman numerals, and he's a huge reason it took over Europe. And the way he chose to illustrate this new sequence was through a fun little thought experiment. In his book, Liber Abaci, he laid out a puzzle about how a population of rabbits would grow under a few simple rules. And the answer to that puzzle? Well, it generates our sequence perfectly. The rule behind the whole thing is just beautifully simple. It's a sequence where every single number is just the sum of the two numbers that came right before it. That's it.
Let's just walk through it. You start with 0 and 1. Add them together, you get 1. Now add the last two numbers. 1 and 1, you get 2. Then 1 plus 2 is 3. 2 plus 3 is 5. And it just keeps going. 8, 13, 21, 34, on and on, forever. It's just a brilliant example of how a simple rule can create this endlessly complex and meaningful pattern. So, okay, we've got a simple rule, and we've got a pattern that pops up all over nature. But that's not the whole story. Not even close. There's a much, much deeper mathematical relationship hiding inside these numbers.
Which brings us to the really big question, right? Why this sequence? What is it about just adding two numbers together that makes it the fundamental blueprint for growth in the natural world?
Well, the secret is hidden in the ratio between the numbers. If you take any number in the sequence and divide it by the one right before it, something pretty amazing starts to happen. The further you go, the closer and closer the result gets to one very specific, very famous number.
And this isn't some recent discovery. Way back in the 17th century, the famous astronomer Johannes Kepler noticed this exact same thing. He saw that the ratios were all zeroing in on a single constant value. And that number is approximately 1.618. You might know it as the golden ratio, or phi. So here's the crucial link. The simple process of building the Fibonacci sequence is fundamentally tied to this major mathematical constant that shows up in art, architecture, and nature. Now, because of that powerful connection, the Fibonacci sequence isn't just some quirk of nature or a fun math problem. No, its influence stretches far beyond that, right into our modern high-tech world. I mean, think about it. In computer science, it's used to analyze how efficient algorithms are. In finance, traders use something called Fibonacci retracement levels to try and predict market trends. It even shows up in the diagonals of Pascal's triangle. And of course, artists and architects have used its link to the golden ratio for centuries to create beautiful, balanced work.
It's just incredible, isn't it? What started as a way to count poetry patterns in ancient India is now an essential tool in fields that Leonardo of Pisa could never have even dreamed of. It really speaks to the timeless, universal power of this pattern.
And all of this leaves us with one last, kind of mind-bending question to chew on. Did we humans invent the Fibonacci sequence to help us describe the world, or did we simply discover a fundamental rule that the universe has been using all along? Something to think about.